A 0.64 nanocoulombs charged particle with initial velocity 5.85 times 10 to the third J meters per second enters a region of uniform electric and magnetic fields. The magnetic field in the region is minus 1.35 K Tesla. Calculate the magnitude and direction of the electric field in the region if the particle is to pass through undeflected. Ignore the weight of the particle. What we have here is a particle that enters a magnetic field that has a magnitude of 1.35 Tesla, and it's oriented in the opposite direction to the positive direction of the z-axis. In this case, we consider that the positive direction for the z-axis is out of the page, therefore the magnetic field will be oriented into the page. This particle is moving with a velocity v0 that is oriented along the y-axis. We need to find the direction of the electric field and the magnitude such that the particle is undeflected. Well, the electric force will be equal to the charge multiplied by the electric field. And because the charge is positive, the electric force will have the same direction as the electric field. Besides the electric force, we also have a magnetic force acting on it, which is applied by the magnetic field B. This magnetic force is calculated as the charge multiplied by the cross product between the velocity and the magnetic field. This cross product gives us the direction of the magnetic force, and according to the right-hand rule, this magnetic force will be oriented to the left. Therefore, if the particle is to pass through undeflected, the electric force has to be oriented to the right and equal in magnitude. So the two forces will have to be equal. But because we write the equality of two vectors that are in opposite direction, we have to add this minus sign in front of one of the forces. So we will have the electric force equals minus the magnetic force because their directions are opposite. And why do we put the minus sign? Is because we write the vectors as being equal, not their magnitudes. From this equation, the electric field will be nothing else than minus the cross product between the velocity and the magnetic field after we simplify the entire equation with a charge q. All we have to do is replace the velocity with its expression 5.85 times 10 to the third unit vector j, and the magnetic field with its expression minus 1.35 unit vector k. You have a minus here and a minus in front, which cancel each other or gives you plus. And all you have to do is multiply the magnitude of these two vectors, and then remember that the cross product between the unit vector j and the unit vector k is the unit vector I. So you can simply write the electric field as the result is the magnitude is 7,898 multiplied by the unit vector I. This shows you that the direction of the electric field is oriented along the x-axis, exactly the same way as the electric force. As you can see from the drawing and from the calculations, the electric field is perpendicular to the magnetic field and also perpendicular to the velocity.